Algebra 1, Day 28. Today we're going to be talking about functions. So we're going to be re-reviewing this again. So let us go ahead and get started on this and get started on our notes. So first thing, a function is a relation in which no x value is paired with more than one y value. Do not repeat my x's. There are 4 ways I can see a function: tables, maps, ordered pairs, or a graph. So here they gave me 2 sets of ordered pairs and they're asking me which one is a function. As usual, the very first thing that I'm going to do is just pick out all of the x values. When sitting here looking at this first set, I see that there are no numbers repeating. That is a function. Over here, I see that the 0 has been repeated, not a function. So the ordered set on the left is a function because it has no repeating x's. And the ordered set on the right is not a function because it has repeated x equals 0. All right, let's take a look at the mappings. So they're going to ask us which one is a function, which one is not. So I'm looking to see if there are any x's that have more than one friend. So over here, x and y, remember we always do it in alphabetical order: domain, then range, x, then y. So I look at these and I see that 4 has 2 friends, so that's definitely not a function. Over here on this side, everybody is just going to 1y. It doesn't matter that this y over here has 2 x's, as long as each x only has one line coming from it. Function. So the mapping on the right is a function because it has no repeating x's. And the map on the left is not a function because it repeats x equals 4. All right. So, of course, whenever dealing with graphs, we use the vertical line test, sometimes called the pencil test, to figure out if a graph is a function. So I'm going to go ahead and get my pencil together here, get a straighter one. Okay. So I'm going to take my pencil, I'm going to run it all the way across, and we'll see if they're going to touch more than once. Nope, it is not. That is a function. Let's go ahead and do the same thing over here. So I'm going to run it across, and yeah, it's touching twice a bunch of times. That's definitely not a function. So the graph on the left is a function because it passes my vertical line test. The graph on the right is not a function because it fails my vertical line test. Now, of course, as part of these, we also talked about domain and range. So, domain is a set of all possible x values of a function. Other names that people can use are going to be x values, input, and independent variable. Sometimes people will even say stuff like causative, which is another word that you may hear. Range, the set of all possible y values of a function. Other names for range are going to be y values, output, and dependent. All right. So again, in order to do our domain and range, we always have to first start with continuous or discrete. Continuous means that they're all connected values within an interval. No gaps, no holes. And we use the notation that includes my inequality symbols. This is called interval notation. Okay, so I can have two different kinds of symbols on these graphs. So if I see a symbol like this that is filled in, sometimes called closed, we would have those with the symbols that have the extra equal sign at the bottom. However, if it's not included, it's going to be open, not filled. And it's going to have the inequality symbols without the equal part. So, discrete functions are separate and discrete values, like in tables, maps, and order pairs. The type of notation is referred to as set. Interesting to note about this means list all numbers. Okay, so let's take a look at the two examples they have here. First thing, I look at this and I say, all right, is this continuous or discrete? Well, they have a list of numbers, domain, range, and I see that it's a list. They're not interconnected because they'd have to be on a graph or an equation that was graphed. So I would say that this guy is going to be discrete. My domain, I'm going to list in order from smallest to biggest. Range, I'm also going to do the same exact thing. All right, next one. Over here, they're going to ask me about my domain, range. I see these guys are continuous because they're all connected. So let's go ahead and start first with my domain. I'm going to come way out here and I'm going to move in and I'm going to see what's the very first part of the graph that I encounter. Right there. Okay, so because this is continuous, I can go ahead and get my intervals set up. So it's going to be -2. Let me move this out of the way. I'm going to take a look at my dot. It is filled in, so it has an extra line. All right, now I'm going to go way out to the other side, way over here. I'm going to come in to the very right point, okay? So that's over here at +4. And it looks like it's not filled in, so no extra line. Now I'm going to go ahead and do the same with the range. I'm going to go to the very absolute bottom of the graph. I see it's located at -3. That guy right there is filled in, so I'm going to put the extra line. Now I'm going to go way up to the top, and I'm going to look to see the very first point that I encounter. I see it's right here. That lines up with +3 on the y-axis. That is not filled in, so I do not put the extra line. All right, so evaluating functions. So for these, there's two different ways that they can have this. They can ask you something like h of x equals -4, or they can say, what is h of -4? Okay, so first thing, let me go ahead and just copy down these two equations. Let me get me an extra sheet here. Okay. All right, so I have these two equations. Okay, let's take a look at that very first one. Okay, so they said h of x equals 7x minus x squared plus 2. So let's imagine they said find h of -4. So this part means that what I am doing is I need to plug in x equals -4. Every single place that I see an x, I change it to a -4. So I'm going to go up here to my equation, and all the parts that are going to change, I'm going to rewrite in a different color. Everything that stays the same is going to remain here in this yellow color. So notice every x became a -4. Now I can start simplifying. So 7 times -4, -28, -4 squared. So remember, I got to deal with the parentheses first. -4 times -4, that's positive 16. Multiply times a negative, -16. Okay, got that. Let's go ahead and keep simplifying. All right, so h of -4 equals -42. This point exists on this line. Now, on the flip side of that, they can also ask me, well, what is the y value? So, what is the x value? So they could say something like h of x, what is x whenever h of x is equal to -4, okay? Let's go ahead and do that second equation as well. All right, so let's say for this one, they said find g of +1. Okay, so I'm going to go ahead and copy this equation over. Everywhere there's going to be an x, I'm going to write in a different color. So everywhere there's an x, I'm instead plugging in a 1. All right, so 1 to the power 3, 1 times 1 times 1, that's 1. 1 to the power 2, that's 1 times 6. So I got an answer. The point 1, 3 exists on here. All right, so I want you guys to go ahead and take a look at the example question, and I'll see you next time.